Good morning, everyone. Thanks for joining this EOSC-hub webinar today. We will wait just a few minutes more and then we will start to give the possibility to others to join.
Baptiste, have you raised your hand?
Yes, just to propose you to switch the display because we see the presentation mode and not the full screen one.
Okay, thank you.
Okay, I think we can start as we have a lot of discussions today. Thanks for joining this EOSC-hub event again. Today the webinar will focus on using compute services in EOSC, experiences and advices from EOSC-hub. Our main speaker will be Enol Fernandez from EGI. We will take all your questions at the end of the webinar. So with the please wait, and with the raise your hand function, you will be able to directly speak with us. Next slide, please. This webinar will be recorded, of course, and will be published online on our website, so we'll be able to access it also for future reference. The webinars page will be available on this presentation, but of course is on the EOSC-hub webinar program page of the website. Yes, we will take again the questions at the end. Next slide, please. I'm Francesca Spagnoli, and I'm project manager of Trust IT Services, and I will be the moderator of this session today. Next slide, please. I will give you just some preliminary information about EOSC-hub for the ones that perhaps don't know, and then we will go directly into the presentation from Enol. So EOSC-hub is a project that is funded by the European Commission and is a project that is quite big. It has inside 20 digital research infrastructures, including EGI, UDAT, and Indigo Data Cloud, that is aiming to offer services, software, and data for advanced data-driven research and innovation. The main goal of EOSC-hub is to provide an integration and management system of EOSC, the European Open Science Cloud, of course, acting as a European level entry point for all stakeholders. We have a huge consortium with more than 100 partners from 53 countries, and the coordinator is Dicting EGI. Next slide, please. Our areas of activity are basically focused on four main areas: services, federation services, federated operations, processes, and policies. As you can see here, the hub is the main entry point for all these kind of services, which includes, for example, data, training, consultancy services, application and tools, as well as storage and computing services. In terms of federation services, we have the EOSC portal and marketplace where everyone can access, and also some services in terms of customer service like help desk, monitoring, accounting, and authorization authentication services for the identification. In terms of federated operations, we have as well a lightweight certification of providers, such as service level agreement negotiations and customer relationship management. And finally, in terms of processes, we are aiming to offer security regulations, compliance to standards, and as well as terms of use, and especially fair implementation of guidelines, so for sharing data in open access. Next slide, please. Today, we will be focusing on two of the main aspects of the services that we call key exploitable results of EOSC-hub, as you can see here in this picture, very well presented. We will mainly focus on the services in the EOSC portfolio and as well as internal services in the app portfolio. Next slide, please. And now I would like to leave the floor to Enol Fernandez from EGI that will present us the computing services of EOSC. Thanks.
Okay, thank you very much, Francesca, for the introduction. So as Francesca was already saying, I will give this webinar on using the compute services in EOSC. This is mostly an introduction for you for understanding what are the kind of services, the computing services that we are delivering in EOSC-hub, and some description of the use cases that we are supporting with these services within the project. So if you go for the next slide. So I have classified the services that we have in three main categories. So we have the federated compute, which would be kind of the basic access to compute from the EOSC-hub. And here we have EGI Cloud Compute, EGI Cloud Container Compute, and EGI High Throughput Compute. Then we have advanced features and services that make use of those resources provided by the federated compute layer with, let's say, more intelligent or smart way of using the resources. So we have things like Docker for running Docker containers inside of any kind of computing resource. And we have then workflow management services like Dirac and the Pass Orchestrator. And then on top of all of those, we have the application services that would allow users mainly to just interact with a single application for a, let's say, a specific domain. And we have here the applications on demand powered by EC3 mostly and the notebooks. So let's get started with the first one, which is federated compute. So if you go to the next slide. Sorry, first I have this introduction on the different services that the EOSC-hub is proposing and offering, and the webinar today is mostly on this bottom line processing and analysis part of the workflow, which is mostly what you can use to get your data, do some analytics, and then produce some results that you can put them into a preservation platform. So we can move to the next slide, and we'll start with federated compute. So next, please. So these services are mostly devoted to provide access to computing resources, to basic, I would say basic in the meaning of raw, that you can use for almost anything. And it allows you to run any kind of workloads on the distributed EGI infrastructure. We have support for 3 different kinds of workloads that are the virtual machines, the jobs, and the containers. So for the virtual machines, we have the EGI Cloud Compute, containers is EGI Cloud Container Compute, and jobs is EGI High Throughput Compute. So let's get to each of them individually. The EGI, yes, you can go to the next. The EGI Cloud Compute Service is a distributed infrastructure as a service powered by the EGI Federated Cloud. Mostly an infrastructure as a service. If you are not familiar with that, it's a service that allows you to start virtual machines and do whatever you want to do on top of those virtual machines. And the idea with the EGI Cloud Compute Service is that you can start those virtual machines, or VMs as we call it normally, in a distributed infrastructure. So you can move your computation wherever your data is, and you don't need to move data around. The features of this service are, first, of course, execution of virtual machines, because this is infrastructure as a service. But then we have some extra features that make it a real federated service. First is the federated identity. So with your same institutional account from university or research institution, you can just log in into all of the different providers of the federation, and you will get access to the services. We have a common virtual machine image catalog, meaning that you don't need to worry about moving around the software that you want to run on your virtual machines. It will be moved to the site as needed. We have access as a graphical user interface, but also in the command line. We support orchestration, which is quite helpful once your computation starts to be complex. You need some sort of orchestration. And we have also central accounting and monitoring. So we are able to understand from a central point what's the consumption of the usage at each of the providers, and whether the providers are working or not as expected with monitoring. So next slide, please. This service has 3 different access layers to get into it. All of them are, let's say, managed or enabled with this blue box that we have on the right, which is the check-in. This is the one of the EOSC-hub authentication authorization services that will allow you to use your credential for accessing the service. So check-in manages access to the different layers, and the layers are, the first one on the top is the graphical user interface, which is meant for, let's say, less advanced users or less techy users. They just can click around and they will get their VMs running. Then we have the federated access, that is the ones using orchestration to deal with several providers at the same time. And we support here several tools, just to name 2, Infrastructure Manager and Terraform. I will get to them later. And then we have the direct API access, where you go directly to the provider and interact with the API. In this case, it's OpenStack. That's the technology we're using everywhere, but in principle, it can be open for any technology. These 2 bottom layers are meant for, let's say, developers or more advanced users that have more knowledge on how the technology works. So on the next slide, I start with this graphical user interface that is called the AppDB VMOps. This is a single web page where you can manage virtual machines on different providers of the federation. Here you can see in a screenshot where this is myself running things on the infrastructure, and I have virtual machines running in Spain, in Italy, in Czech Republic, and in Belgium. So all of this I can control with just pointing and click into this web interface. It's quite easy to use, and it has like a wizard-like solution to start your VM. So just selecting the different options, and at the end you will have the thing running, so you can then run your workloads. It's integrated with all the features of the federation, so you can easily get to all of the providers, understand the availability of those providers, get the images or understand which are the images available at each of them, and so on. And all of this is powered by the Infrastructure Manager orchestrator that I have in the coming slides. So if you go to the next. The orchestration, which is where this Infrastructure Manager lies, is the layer that allows you to deal with different providers in a common way. Here we are not close to a single technology. We have several of those supported. The main ones would be this Infrastructure Manager and Terraform. Infrastructure Manager is part of the EOSC-hub project, so it's developed within the project, and Terraform is from a commercial company in the US called HashiCorp. It's an open source tool that works perfectly fine with OpenStack, and therefore works fine with the EGI infrastructure, and it allows you to, with a near API level abstraction, to interact with the providers in a uniform way. I will get into infrastructure managers in the coming slides. So if you go to the next. Next, please. Okay, so infrastructure manager is a service. So it's a service you connect to that deploys virtual infrastructure on top of any cloud resources, including the EGI ones. It uses a code file to describe the infrastructure, and can be RADL, which is the infrastructure manager own language, but it also can be Tosca, which is a standard. And that file describes what you want to have in your infrastructure. Let's say I want one virtual machine of this size with this kind of image, and another one of the other size and another kind of image, and I want them to communicate in this way. So you describe all of that, and you send that description to the infrastructure manager, and it will handle all the deployment, configuration, installation, monitoring, and updating that virtual infrastructure for you. It supports a wide variety of backends, so including the EGI cloud, but you can also use it with, let's say, commercial providers like Amazon. So it's very easy to, within a single tool, to deal with different platforms or infrastructure providers without needing to change your description. So if you go to the next slide, this infrastructure managers, it's featuring some DevOps capabilities. So it allows you to mostly describe your application or your deployment as code. It's using Ansible and has like a predefined recipes for common deployments. So if you are looking for deploying like a batch system or an NFS server or this kind of common things that most people use from time to time, we have already recipes that you can just mention in the description and they will just work. Besides Ansible, it's also supporting Cloud Init, so it runs almost on any virtual machine that you can think of. It's a service that has two different interfaces, so it has an XML RPC and a REST API, and you can connect via command line application and also via web-based graphical user interface. We mostly use it in a command line way in the EGI cloud. And this is open source and it's available here in GitHub, and its development is part of the EOSC-hub project. So if you go to the next. So that was the second layer of the access to the EGI cloud. The third layer is directly going to the infrastructure service, to the OpenStack, and we support here two, let's say, modes. The first one is going through the dashboard of the individual providers, and here you see this is one provider in Czech Republic, CESNET, and here you can see you can authenticate with the EGI check-in, and then you will be inside the regular OpenStack dashboard that you may be familiar with, and you can do the operations you normally do in this kind of platforms. And on the right, I have this screenshot of a terminal that's using one provider in Catania, INFM Catania in Italy. And it's basically interactive with one of the OpenStack commands for showing the images. This is just an example. You can use all the OpenStack commands as usual, just using the credentials from check-in, and it will work. So if you go to the next. One of the nice features, I believe, of the cloud compute is this catalog of virtual machines. And this is powered by the AppDB, the applications database. This is a web portal where you can register your virtual machine images. A virtual machine image is basically the software you want to run on your virtual machine. And here you register whatever you want, you are interested in. We have lots of, let's say, basic operating system images like this CentOS, Ubuntu, etc. So you have the basic operating system will be there, but if you have more specific software needs with scientific software, you can also upload it here and it will be made available in the different providers. And the idea is that every community that we support, every user group that we support can go to this application database and say, okay, I'm interested in the CentOS site and the Ubuntu server. And if you click and select those, they will be made available to the providers that you have access to, and you don't need to worry about moving the images there or converting them to the format that the provider uses. So if you go to the next slide. That was mainly the EGI cloud compute, and now I will go to the EGI cloud container compute. So the first one was about running virtual machines. Now we are talking about running containers. You can, of course, run containers on top of a virtual machine. That, in fact, we have one in the AppDB, which is, we call it the EGI Docker image. You can just start that on the EGI cloud providers, and you can just use Docker. But if you have an application that is growing and has multiple containers that need to interact with each other, you need to manage more than one virtual machine where your things will run. Things start to be not so simple with, let's say, Docker simply. So you need to go to something that is able to manage and orchestrate everything on top of those resources. And in this case, we use Kubernetes. Kubernetes is, I would say, de facto standard for container orchestration. It's supported on every major cloud provider, Amazon, Google, Azure, all of them support them. And in the EGI cloud, we also support it. And the EGI cloud container compute is a service that allows you to automatically provision this Kubernetes cluster, so you can just use Kubernetes without worrying too much about the underlying hardware and resources. And the idea is that you go to the EI Cloud Container Compute, request a new cluster. This first will provision the VMs using the orchestration tools. Then it will deploy Kubernetes cluster on top of those virtual machines using Ansible and this kind of DevOps-like recipes. And then at the end, it will provide the user the right endpoints so you can use the native Kubernetes tooling as if you were locally using the cluster. And this is using EC3 that I will come back to EC3 later, that allows you to have a scalable management of the resources. So the cluster that you are deploying can grow or shrink depending on the load that you are putting in your application. So if you go to the next. So EC3 is the tool managing this kind of system, and it deploys Kubernetes, as I say, with Ansible and with elasticity. So whenever your load increases, you will be able to automatically have more nodes into the cluster to support that load. It has access via graphical user interface and command line access. Here you can see screenshot of the, let's say, of the last step or almost last step of the submission of a cluster into the infrastructure. You see here some details like what's the provider. This was in 923 address in France, running some Ubuntu with, it was kind of a small virtual machines, one CPU, 4 gigabytes of RAM, and starting with one node. And this totally integrated with check-in AppDB, so you can use your identity as with other services, and will take the images from AppDB. If you click on the next, you can see, if you go to the next, yeah, you can see here the result. Once this is properly configured, you will see a screen like this saying this was deployed successfully, and these are the details to access via SSH, but it can also provide you the Kubernetes detail, so you can connect with, let's say, kubectl or similar tools. So next, please. The third service that we have in this category is the high throughput compute, which is what people normally know as the grid. And it's kind of a very big batch system where you can submit jobs and we'll get the results back. And the idea is that, yeah, we have a distributed infrastructure. Each of these providers have this kind of C node, computing element node, where you submit the jobs, they will be run eventually, and then you will get back the results. And this is supported by more than 200 providers all across Europe and the world, and allows you to submit hundreds or even thousands of computational tasks that do whatever you want to do at a big scale. If you go to the next slide. In order to move software to this big infrastructure, to the high throughput compute, we have CVMFS, which is the CERN VM file system. And this is allowing to distribute software all across the federation in a read-only file system that anyone can access. And the idea is once you put something into this CVMFS, it will be available everywhere, and you can just reference, and it will be in a /cvmfs/ei.eu, and you will find there your software. So there is a interface for the software manager to upload things, and once uploaded, they will be available everywhere. It's supported by a distributed setup with lots of caching, so it's quite fast, and it's based on HTTP software and protocol. And this is available everywhere. So once you put your software there, it will be available for your jobs in the high throughput compute. If you go to the next. This is kind of a summary of what I have said so far. So we have the 3 EGI basic computing services, the cloud compute, cloud container compute, and high throughput compute. And you run different kind of things on each of them. So virtual machines, containers, or jobs. You distribute the software in different ways. In the cloud compute, it's virtual machine images in AppDB. Cloud container compute will use the standard for containers, which are the registries. In a high throughput compute, we use CVMS that I just explained, and you run different things on cloud compute, virtual machines for mostly moving applications that you have in-house, moving them to the cloud. Cloud container compute, you run cloud native containerized applications. In high throughput compute, parallel computing tasks to analyze large data sets. So depending on your needs, you should look into one or another. Cloud compute is more configurable. You can do more things, but it's more complex. High throughput compute, you have, let's say, less power to do stuff. You are more restricted, but it's easier to manage because you just submit the job and don't care about the underlying infrastructure. And the cloud container compute is kind of in the middle, maybe closer to the cloud compute than high throughput compute. And it's nice because it hides you the complexity of Kubernetes, but of course, Kubernetes is not simple, and you need to learn how to deal with that. So you can go to the next slide. We go now to the, let's say, services that run on top of these services or features, advanced features for those services. So you go to the next. First thing is GPUs. This is something that people ask a lot, especially now with all the machine learning, artificial intelligence. GPUs are quite helpful for those kind of workloads. And we support GPUs on the services that I just mentioned. So in the cloud compute, cloud container compute, and high throughput compute. And basically we have some providers that have these kind of GPUs available, and you can just use it by selecting the right flavors. That's how we call the templates for starting the VMs. And we have the images with the drivers ready to use. So it will be ready to start and not worrying too much about configuration. Cloud container compute is the same. We have the configuration ready. So if you select a flavor with GPU, Kubernetes will be configured for that. In high throughput compute, you just need to flag your job as GPU enable, and the infrastructure will take care of selecting the right sites. So if you are wondering or you need GPUs for your workloads, you can count on these services being available. If you go to the next. One thing that also people ask a lot is how can I run my jobs with that are distributed as Docker? So normally in the high throughput compute, we have this CVMFS, so to distribute the software, but maybe you have already your software as a Docker application or a Docker container. And UDocker is one tool that is developed in EOSC-hub that allows you to do that. It's allowing to run application in Docker containers without using Docker. That means it does not need any kind of privileges. You don't need root account, and you can do it as a regular user without installing anything else. It's just a Python script that you download and you start it. It will just run as a normal user from the command line. It's uncompressing the image and running whatever is inside of that. Of course, you cannot do everything you can do with a regular Docker container. You cannot start servers and start listening to connections from the outside world. But for most of the cases, that's not really needed. It's quite handy for this kind of batch systems where you don't have any privilege. You can just run a script. So one thing you can do is just download UDocker, as I said, and start the container. So if you go to the next slide, this has been running by several communities, and it's been tested in several workloads. For example, this is using GPUs for some application called DSBs. And here you can see this is comparing the execution time from a physical node running CentOS 7 comparing to Docker, let's say regular Docker installation in Docker in CentOS 7 or Ubuntu, and also compared to uDocker, which are the green. So you can see the performance is quite similar to the, let's say, native physical running in the CentOS 7 host. So it doesn't bring too much overhead, and it's even less than running with Docker, which is quite nice. And this is running with GPUs. So you can use this kind of hardware for using Docker. If you go to the next slide. So here's a similar thing with TensorFlow, also comparing different ways of running containers. And this is using, let's say, Docker out of the box, uDocker, and Singularity, which is another tool that people sometimes use for running containers in batch systems. So you can see uDocker is the smallest, has the smallest execution time, so it's the fastest, and therefore the best for this specific use case that was training a model to recognize handwritten digits from this data set. So you can see uDocker is quite powerful tool, and it's also very easy to use. As I said, it's just downloading and starting your job with that. So if you go to the next slide. uDocker is available in GitHub. You can just download it from there, and the full documentation. If you go to the next slide. Next, please. So if you have multiple or very large workflows where you have lots of jobs, you will need some kind of workload management. And this is where the EGI Workload Manager comes very handy. This is also supported by the EOSC-hub project development, and it's powered by a tool called DIRAC. DIRAC is a framework for building distributed computing system, and it's aggregating multiple types of resources from cloud, from the high throughput compute, even from local clusters, and make them available for you to run your jobs in an optimal way. This is coming from the high energy physics community initially, but it's now available for almost everyone. So it's available for everyone and now used for lots of communities like astronomy or life sciences. If you go to the next slide. So DIRAC provides this access to different kind of computing resources. It has a command line interface. It also has a web portal. It has Python and REST APIs, and we are working also on interacting with it from Jupyter notebooks as a prototype that will be soon available. It supports massive amount of jobs being sent to the service, and it will be managed without any issues, and also supporting massive amount of resources at the backend. And we can tune it to meet the needs that your community may have. So this is mostly to submit jobs, but if you are in the cloud, if you go to the next slide, we have the Indigo Pass Orchestrator that is also coordinating the provisioning of resources on top of cloud infrastructure, not just using one provider, but several providers in coordination to deliver whatever application you are developing. And this is working on jobs that will be, well, jobs or application that is composed by Docker containers running on Mesos mostly. If you go to the next slide. So the Indigo Pass Orchestrator is here, and you can see it supports different kind of clouds. So it's supporting the public like Amazon, Azure, Google, but also supporting, let's say, private or community clouds like the OpenStack, OpenNebula, and it's also integrated with data management services. So it will place your workloads near to the data as needed. Whenever you request to deploy your infrastructure, the Pass Orchestrator will look for the better or the best resources that it can use to deploy your infrastructure, and it will do so. And once done, basically you can just use it. And it also has nice features like this try, and so it can try and deploy on a site. If it doesn't work, it will query for other sites and will try and deploy on a second site. So if you have an application that it's cloud-like, the PaaS orchestration will facilitate any kind of deployment on the infrastructure. If you go to the next, just some more features. So it automates the provisioning of compute and storage resources on different providers. It selects the best resource based on criteria like the SLAs that you have with those providers, the availability, the monitoring metrics. It will query the status of the providers to understand whether it can be used or not, and so on. It will resubmit deployment in case of failures, and it supports data orchestration with tools like Lucio from CERN. So next slide, please. So moving to the, let's say, last layer, which are the application. If you go to the next, here we have mostly two services. One is the applications on demand that is meant to host applications that you just select and start to use it. We have scientific applications like Chipster, NAMD, ECAS, and many others. We have a catalog available in the EI marketplace, but if you are interested in a specific thing, you can also request and we can talk about supporting new ones. The idea is that it will access some cloud and storage resources to host and scale up the application, and it does it by using two hosting frameworks. One is the EC3 that we use also in the container cloud container compute of EGI, and the Science Software on Demand platform that is coming from INF and Catania. And it also provides the VMOps dashboard. So I will go with some details on the EC3 on the coming slides. So next. EC3 is this tool that allows you to deploy virtual elastic cluster on top of any provider. So it's not just the EGI ones, and has predefined templates to configure the results with Ansible. Kubernetes is one, as I said before, for the EGI Cloud Container Compute, but there are many others that you can just use to start your cluster. We have Mesos, which is also about running containers. We have Slurm, Torque, SG, HT Condor, which are batch system, Nomad, which is a cloud native job scheduler, and there are many, many others. And there are also extensions to those templates. So you, for example, can deploy Slurm with NFS, so you will have the nodes with a share file system, and many others. So if you go to the next slide. And this works with a wizard that has 6 steps. So it's all point and click. Basically, you select what kind of deployment you want. For example, a Slurm. Then you select the endpoint where you want to deploy, the operating system you want to use, the size of the virtual machines. So for example, this is 2 GPUs, 2 CPUs, 4 gigabytes of RAM. How many of those you want, the cluster size and name, and finally you have the summary where you can click submit and it will just happen. So it's very easy to deploy a full software stack that is useful from the first minute. If you go to the next. The other application we are supporting in EOSC-hub is the EGI notebook service. This is Jupyter hosted in the EGI cloud that offers notebooks as a service. You just go there and log in and start using them. If you are familiar with the notebooks, this is kind of a document where you can put together documentation, code, and the output, and you can interact with it. So it's supporting lots of languages. For example, Python is kind of the more common, this Python example, and you can write the code, execute it, and see the output as text, but also as figures that you can interact with. You can log in just with the check-in service, and whatever files you create here, it will be persistent, so you can come back a month later and it will be still there, and it's using the EGI computing and storage powering those notebooks. So if you go to the next. I will now go into some example of how these services are used in the EOSC-hub project. So if you go to the next, starting with WNMR. WNMR is one of the thematic services of EOSC-hub. This is a community of practice of structural biology, and they have 7 different applications of platforms. They are listed here. Basically, all of them are similar. They have a web portal where you can log in and select the kind of job you want to do, click on submit, and this will create a job that will be submitted to the RAC, to the workload manager that I was saying before, submitted to the AGI high throughput compute. With UDocker, it will run the software as Docker containers, and the output will then be back available in the web portal. So this 7 of those portals, all powered by the same kind of processing chain and powered by DIRAC, so Workload Manager, UDocker, EEI high throughput compute, and the different storage services. So if you go to the next. This is another thematic services of EEI. This is the of EOSC-hub. This is OpenCoast. OpenCoast is a service that it's meant to create forecast system for the coast, and it's producing daily forecast of water levels and 2-dimensional velocities over different regions of interest over periods of 48 hours. And this is kind of similar to WNMR. They have this web front end that will generate the jobs that need to be done to do the simulation and generate the forecast. So those will be sent to the workload manager, to Jack, that will be run on the EGI high throughput compute, again, using UDocker for distributing the software, and then the results will be made available in the portal. So, well, you can see here there are lots of other services also mentioned, but as this is just focused on the compute, I just mentioned those mainly. So if you go to the next one. We are also supporting the EOSC Digital Innovation Hub that is part of the EOSC Hub. Here we had a set of 6 initial pilots in the project that are listed here. So Action Seaport, Space Weather, for Draco Observatory Server Hub, Bot Mitigation Engine, Smart Sport, and Sport Smart Video Analysis and Furniture Enterprise Analytics Data Form. If you click, you will, in the next, just go on until all of them change. Yeah, thank you. So this is mostly running on cloud, is cloud applications, and I would say most of them are running on the EGI cloud, either directly as going directly to the infrastructure as the infrastructure as a service layer, or using some orchestration like the PaaS orchestrator. And this has been quite successful, I could say, and I would say this has been a quite good relationship with the business, also for this kind of business using this kind of services, and proving that that's also possible. If you go to the next one. Then we have another thematic services, which is DODAS. DODAS is meant to create virtual clusters on top of a distributed infrastructure. This is originally was meant for the CMS experiment in the LHC, but can be used by any kind of science or any kind of other experiments. And here we have some plots of an experiment we did last year, where we used DODAS to deploy a virtual cluster on top of 4 different cloud providers, and it was used and exposed to the CMS collaboration as a virtual site, and it was actually consuming jobs from CMS in production. And they were let's say, magically distributed across all the providers transparently without the users knowing that instead of a single thing, it was a virtual cluster powered by 4 different providers. This is using the path orchestrator on top of the EGI cloud providers. If you go to the next one. This is one of the EOSC-hub early adopter program use cases. This one is about big data analytics for agriculture. It's using Earth observation data from the Copernicus satellite, and with that is using some machine learning algorithms to determine what kind of agriculture crop is growing in each of the fields. We are doing this project collaborating with not just the EGI cloud providers, but also with EODC and CreoDias, which are part of EOSC-hub. So we have created a hybrid cloud compute setup for supporting this project, which I think is quite interesting. So we are not limited just to the EGI cloud providers. We can be open to other providers and we can connect with them. If you go to the next. This is another competence center from the EOSC-hub project. This is IceCat3D. IceCat3D is a radar, research radar for atmosphere, ionosphere near Earth space. That's an ESFRI landmark since 2018. And this is in EOSC-hub, they are delivering a new platform to be able to deploy the necessary tools for doing the data management and processing of this radar data. And it's using mostly Dirac, the EGI workload manager, to distribute the jobs in the infrastructure and also moving the data around as needed. If you go to the next slide. This is another example of the early adopter program. This is using the EGI Cloud Container Compute, the Kubernetes setup, to deploy what they call the ADA lab. Is quite nice and easy to use interface where you can run material science applications just by clicking. And this is running on Kubernetes, and for this early adopter program use case, what we are doing is providing this access to Kubernetes and testing the scalability and testing this for big amount of users and seeing whether this can be done or not. If you go to the next. This is another early adopter program case supporting EmbryFair project that's about the environmental science cluster. And here we have 3 different use cases supported by this early adopter program. The automatic cloud execution for data workflow, continuously testing and integration for Embry services, and notebook-based environment for fair data access and services. I just wanted to highlight here that in this case, they are using this Jupyter notebooks, this EGI notebooks service to being able to submit, let's say, jobs to a cloud infrastructure, jobs as Docker containers. So in this case, they are using a very high level application like notebooks and interacting from that application with the lower level kind of computing resources with Docker to run the workloads I need. And if you go to the next. So that was some examples of the EOSC-hub usage of the compute services. And now just to summarize, if you click next, basically I tried to show that how the different EOSC-hub computing services work together as a single federated solution that you can use to run your workloads. You can have from the very powerful and fully customizable infrastructure as a service of the EGI cloud compute to very high level platforms like the notebooks. And in between you have things like the EGI high throughput compute where you can submit the jobs using the workload manager. You have the infrastructure manager that allows you to orchestrate computing infrastructure. So on the EGI cloud, you have the orchestrator to automate all the provisioning of also infrastructures in the cloud. You have the container compute to run Kubernetes on the EGI cloud. You have EC3 to deploy easy deploy clusters on the infrastructure. And you have Docker, of course, to submit Docker jobs to whatever kind of resources, including the EGI high throughput compute. And if you go to the next one, all of these services are available from the EOS portal. So if you're interested, just go there to the EOS portal and start requesting those. And these requests will come to us and we can start talking about supporting you. And that's the end, I believe. Go to the next. Yeah, thank you.
Thanks a lot, Enal, for the very interesting presentation. Let's see, we have 10 minutes, so let's see if we have some question. I see already Dragos is asking to talk. Let's try.
Dragos, if you want to speak now, you can speak.
Hello?
Dragos?
I think you're muted, Dragos. He's trying to reconnect. So let's give the floor to Baptiste, perhaps first. He was asking to talk, I think.
No, that I just forgot to lower my hand. That was before the presentation. Sorry.
Okay, no problem.
Okay.
Any question for Enal? Don't be shy. Looks like everything is very clear from the presentation, and indeed it was very nice and clear. Nobody who likes to raise an hand and ask questions? Perhaps a question that could be interesting, Anal, is what is the current status of, let's say, actions that someone would like to join the services should take as a path, let's say, if there is a procedure?
You mean, so there are two things. For using the services, you can just go to the EOSC portal and there is this kind of marketplace where you can request. So there is kind of buttons on every service where you can click and request the service. And there, for example, for the EI cloud, which is the one I have like more familiar with, you will have a box where you can select the kind of resources you are interested in, like whatever number of CPUs and memory. And that request, once done, will come to the support team of the EOS-hub project, and we will just be in contact with the user to get it started. If you are interested in becoming part of the providers of the EOS-hub or EOSC or EGI, mostly it's just contacting me will be the first step, and I would just redirect to the right procedures that we have in the documentation.
Okay, thanks a lot. For getting in contact with forecast representative, for example, because it could be interesting for another project we're running, we can directly contact you, or there is another contact that perhaps you can provide us.
Sorry, contact for what?
For getting talking with people from Forecasts project.
Yeah, that's you can contact me. That's
okay, sounds good. Any other question? I don't know if Dragos has been connected again. Let me check.
No, I don't see him.
Okay. So if there is any other question, I would like to thank you all for joining the webinar. There will be another webinar. Actually, there will be other 2 webinars in the series of the EOSC-hub one on the 1st of December on managing services and resources for EOSC, and another one, the final one, on the 15th of December on EOSC-hub data sharing policy recommendation and Elixir authentication authorization infrastructure. So if you are interested in those webinars, please register on our webinar program webpage. And I hope to see you all there. And thanks a lot and all for the presentation. Have a nice afternoon.
Thank you.
Bye-bye.
Thank you. Bye-bye.